In this video, we will look at how to create expressions from an information given, how to graph relationship between variables, and how to read information from this graph. You can pause the video and read the question. First question asks us to find the volume of the toy. So the toy is comprised of a cylinder. The volume of the cylinder, we know that it's area of the base pi times x squared, the radius of the base is x, times height. So it's going to be pi x cubed. The volume of the cone is given here and is going to be 1/3 area of the base pi x squared times h, and h is 6. So it's going to be 2 pi x cubed. Oops, I have made a mistake. 2 pi x squared. Meaning that the total volume is pi x cubed plus 2 pi x squared. I keep an eye on the answer given. Students sometimes are concerned when they see or show that question, but actually this is easy because I'm given the answer. I can think of the question as find the volume, and you must get this answer. So it's given the answer. I see the volume is factorized, so I'll try to factorize as well, and pi x squared, and I'm going to have x plus 2. Showing all these steps is enough to get full marks in question A. Now I'm asked to draw the graph of v against x. So I need a table of values, and I want to see for different values of x what is v. And I'm given values between 0 and 5. So it's normal that I will take whole values. But if I see at one point that this information is not enough to draw a nice graph, then I might consider other points in between these values. So I'll be using my calculator, which is already in the table mode. And I will input the value of the function, which is pi times x squared times bracket. I always like to put the multiplication sign there because calculators behave sometimes strangely. X plus 2. Close the bracket, enter. Start at 0, end at 5, and the step is 1. So for x equals 0, the value of y is 0. Value of y is 0. For x equals 1, the value is 9.42 to 2 decimal places. The next value is 50.27. For x equals 3, I get 241.37. So I need to be very careful on how I take the scale on the axis, 60. And for x equals 5, it's going to be 549.78. I copy the values on the next page. So I will think now on how to draw a nice graph. You'll of course use a ruler. I don't have negative values for x, So my x is from 0, 1, 2, 3, 4, 5, and my y should go up to almost 600. So I'm counting 100, 2, 3, 4, 5, 6. So it makes sense to take 100, 200, 300, 400, 500. Okay. The points are for x equals 0, y equals 0. For x equals 1, y is 10, so it's very, very small. For x equals 2, y is 50.27, so somewhere here. For x equals 3 is 141, so almost 150. For x equals 4 is 300, 1.60. For x equals 5 is 550, almost here. So this is my point 600. I always need to label the axis, so this is x versus the volume. This is a graph. This is part of the graph of the cubic. We learned that the graph of cubic has an S shape, which can come here somewhere, but this is the part that I'm going to draw. It should look this way. You might think that it looks like a quadratic because we don't see the other part of it. To visualize better, I created this graph in GeoGebra, the same graph. So I start by typing the equation. I need a pi times x squared times x plus 2. Remember that this was our graph, and it is the shape of the cubic. However, I need just x between 0 and 5, so I need just this part of it. So this part will disappear, also because, see, the ratio between x and y axis is different, is not 1 to 1. That's why I see it in a better view. So I'm trying to do this in GeoGebra. I think I struggle a bit to remember how to do it. And at the end I figure out that if I right click, I have the ratio between x and y axis, which is 1 to 1. But in my case, I chose 1 to 20. I was not satisfied, so it should be 1 to something bigger. But then I choose something which was too big. I think I choose outside the screen, so it was too big. And I try 1 to 100, which makes sense. It's 1 to 100. So if I look at this graph, I would have seen that actually that's the best choice, 1 to 100. And see, it is exactly our graph. So it's part of a cubic, but we don't see it all. Now I brought in here the next two questions so that we can answer them using the graph. Use your graph to find the volume of a toy with diameter 7. So if the diameter is 7, let us remember what x gives me. Looking back at the problem, at the diagram on the previous page, you can pause. The diameter was 2x. So if 2x is 7, it follows that x is 3.5. Of course, if I'm looking at x equals 3.5, it's somewhere here. If I use my graph for x equals 3.5, I see that it's about probably a bit higher than 200. So volume, it's about 200, let's say 5 centimeter cubed. It's not an exact answer. If I want to find the exact answer, but they ask me to use your graph, so my answer is good enough. However, I'm curious to see how accurate I am. In some cases I can check, in other cases I can't check. If I want to check, I will need to put x equals 3.5 in my function. So I will have pi times 3.5 squared times 3.5 plus 2. And if I compute this using my calculator, I see that I get 211.662 to decimal places. See, given that it's read from a graph, my answer is very accurate. If I'm asked to use a graph, I don't need this step. I just do it for myself just to check my work. Let us move now to question D. What is the curved surface area of the cylinder if the volume of the toy is 300 centimeter cube? So now I know that the volume is 300 centimeter cube. Therefore, I'm looking at the volume axis. So 300 centimeters cube is here. Therefore, my x seems to be around 4. Yeah. So I'll take x as being 4. I can see that's accurate exactly from that graph. It's very slightly less than 4, but with this big number I can choose 4. So I'll need now to look at the surface area. Let us remember that my toy looked like this. With the diameter being 8, in this case is 2x, the height is 4, and this height here is 6. Surface area is formed by the area of the base, which is pi times r squared, plus the curved area of the cylinder, the area around the curved area of the cylinder, the area around the cylinder is 2 pi times r times h, plus the surface area of a cone. The formula for the surface area of a cone was pi times radius times the length this length. But what I have in my cone is this being 6 and this being 4. So to find what L is, I'll do square root of 6 squared plus 4 squared, which is square root of 36 plus 16, 52. So in my case, it will be pi times r times square root of 52. And if I put all this in a calculator, I can calculate the surface area, which, if I input everything correctly, will be 241.41 centimeter squared with 2 decimal places.